Here's an interesting problem. Find the volume of the solid obtained by rotating the region bounded by y equals natural log of x. Y equals 1, y equals 2, and x equals 0, which is the y-axis. Okay, so I already tried to do a good drawing for you. Here it is. Okay, so y equals natural log of x. Well, how do I, graph that? I know that y equals natural log of x is the same as saying y equals log base e of x. And we know by the rules of logarithm that this base to this power equals the argument. So it's the same as saying x equals e to the y. Well, I can go ahead and make a table of value. And this time, instead of choosing x, I'm choosing y. Notice that if I choose 1 for y and plug it in, so I get x equals e, because e to the 1 is e. When I choose y to be 2 and plug it in here, I get e squared. So I know the point of intersections are e comma 1 and e squared comma 2. All right, and so this is the region right here that we are going to be rotating about the y-axis. And if I rotate that about the y-axis, I'm getting something really similar to this. That's the best I could do for drawing. And so it's just like stack of discs, of different size being right, and going from here, from 1 to 2. And so if I cut one of the slides of disc from this stack, a cross section is a disc with radius of e to the y. So the radius right here, let me choose maybe red. So let's say that this is one slice. And so you can see the radius right here is determined by my function e to the y. So, because remember that we said that we had y equals natural log of x. And then we said it's the same as saying x equals e to the y. Okay, let me go to the next page now. And now I'm ready to for the setup. So we know that the area of any of the slice of a disk is pi r squared. What is radius? E to the y. So pi r squared. And volume is from 1 to 2 pi r squared dy, of course. And so I'm going to pull the pi out because it's a constant. E to the y to the second power is e to the 2y right here, dy. Let me go to the next page, and finally taking the integral. Remember that the integral of e to the x is e to the x. But if you have e to the, let's say, 2x, then you have the integral is going to be e to the 2x, but you have to do the chain rule in reverse. So the integral of e to the 2y is e to the 2y, but now this 1/2 is coming from chain rule in reverse. Once again, if you take the derivative of e to some u, so it's e to the u and then du dx. So you multiply by the derivative. But when you're doing the integrals, so it's chain rule in reverse. So you have to divide by the derivative of the power, in this case 2. And dividing by 2 is the same as multiplying it by 1/2. Okay, this 1/2 is a constant. I'm going to take it out, and when you multiply it by pi, 1/2 times pi is pi over 2. And then plug in the 2, subtract it, and then minus when you plug the 1 for y, and you get volume equals pi over 2 e to the 4th minus e to the 2nd. And if you need the approximation, of course, you can use a calculator, but I'm not going to. Okay, I think this was an interesting example.